Welcome. In this video I talk about elementary data types, integers, floats and strings. The video will be fairly short, but I also mention a little bit about arithmetic and overflow detection. Let's look at the first example. Here I declare a variable of type u64, which is a 64-bit 2's complement integer, and an I64, that's a signed integer. So the U64 is unsigned and the I is signed. We have sizes of 8 bits, 16 bits, 32 bits, and I believe even 128 bits, and of course 64 bits. If you look at the type of this declaration here, you see it is 8-byte size and aligned 8. And here I have put explicit type annotations, such that the compiler knows what type of integer I need here. This is a way to print values. You can just print integers as you would expect. If I run this, I see 123 and minus 123. There's also floats. Here you have a 64-bit float, which would usually be denoted double in C++, and here's a 32-bit float, which is denoted float in C++. They behave exactly as expected. Here's the type bool. Bool can have values true and false and can be printed as true and false as expected. Note that, for example, in if statements, you have to have a bool value. You cannot just implicitly convert a different type to bool. As you see, they are printed as true and false. The next example is a character. A character is declared exactly as in C++. However, the character type has 4 bytes size because it can take a full Unicode character. Here is how the standard library allows you to look at the size in bytes of a type. Just use stat mem sizeof, and you can see this will show the character and 4. And indeed, the character takes 4 bytes. There's also an integer type which is as wide as the machine word. It's called usize, and there's a corresponding isize which is signed. On my machine here with 64-bit, it is 8 bytes wide, and we can also show this with the stat mem sizeof function. Indeed, 8-byte wide. In this example, you see strings. S is of type string. The type string keeps its allocation, so it's an owned type. Whereas if I just put a character constant, a string constant here, I get the type &str, which is a string slice. The two have in common that they both always point to UTF-8 data, and the string slice also knows the length of the string, but it doesn't own the allocation. But with respect to printing, you can use them in the same way. Arithmetic is fairly standard. If you have variables of the same integer type, then you can just use plus, minus, and so on, just to do arithmetic. So this here we'll write 1, 2, 3, 4, 5, 6, and the sum. And indeed, it works. Note that the types have to match. If you try to add different types, like here U64 and U32, then the compiler will immediately complain that this is not possible. You cannot add 2 different types. Therefore, in this example, we would have to cast the U32 to U464, and I do this just by saying as U64. As binds tighter to than the arithmetic operations, so therefore I can write it like this, and it builds and runs as expected. Let's talk about integer overflow. If I try to add 2 U8 values and it produces an integer overflow, let's see what happens. If I do this, I get indeed a panic, because integer overflow is detected in debug mode. If I do this environment variable here and run then, I get more details. I get the full stack trace, and I can see that it happens in the addition. Note that if I build and run with release mode, nothing is detected and I just get the two's complement overflowed value. That's important to know. In debug mode, overflow is detected. In release mode, it isn't. As you can see, integer types and arithmetic has done a huge amount of simplifications in comparison to C++. Basically, all this unholy, undefined behavior with respect to implementation of the integer types, whether or not overflow is detected, whether it's two complements or not, and what happens if you add and subtract different types of integers is all gone, because it's all well defined. No undefined behavior can essentially happen. That's a huge simplification, which I very much like. And that is it for this video. Thanks for listening.